start off today with a setup on this early 90s Gibson J-45. It shouldn't be a J-45, it should be a J-50 because it's got a natural top. But, you know, Gibson forgot its own nomenclature there for a while. This was a guitar that was made in the Bozeman, Montana shop. It's in overall very nice condition for a guitar that's over 30 years old. I'm not sure it ever had anything beyond the initial factory setup in that time. Saddle seems like it's at full height. But the owner says the truss rod has been played with and the nut in there might be mangled. So we'll see. He also sent along a picture that has both of us a little stumped, a little surprise under here. So let's check its vitals first of all. Action on the bass side is just about 8/64ths. And on the treble side it is 6/64ths, which is a bit high. I'm going to check the neck relief, which is the amount of forward bow in the neck. To do that I've got a capo at the first fret, and I'm going to be holding down the 6th string around the body joint, and I will measure that. I always do it at the 6th fret using a feeler gauge. Slide that in between the bottom of the string and the top of the fret, and it's somewhere around 14 to 15 thousandths, which is about twice what I'd ideally like to see. We'll see if this truss rod can be adjusted. Looks like the truss rod cover might have a little split in it where the screw goes through. It does. Whoa, yeah, that's pretty far gone. Yeah, it's been severely rounded off. Here's something I'm noticing. This guitar currently has Kluson reproduction style tuners on it. At some point in its life it had a much larger, I'm guessing those are like Grovers or something, with a much larger washer which has embedded itself into the finish on the headstock. I'll loosen the D and G strings and move them out of the way and see if we can make that thing move. Of course, this is your standard truss rod wrench, which often comes with a guitar. Sometimes they don't. This one I've lopped the back. It's like a protuberance back there that looked like a bullet, which did not want to fit in a particular guitar, so I ground it down. But this is what you ordinarily get. Yeah, so that I think will work. This is a longer purpose-built nut driver, also 5/16, which can get you a little bit more purchase and extends on beyond the end of the headstock, so you can really sort of give it some turns, and that's working just fine. So I could probably make this work. I think we should see if we can just replace it, because if it's mangled now, odds are it will get more mangled in the future. When swapping these things out, it's always a good idea to lubricate the threads a little bit. I'm using some conservator's wax. You could also use Vaseline, tiny bit of white lithium grease or something like that. Okay, story time with Uncle Ted. On the right here, you will see an authentic Gibson truss rod nut. You're going to notice that the faceted flat surfaces here are relatively short. To confuse the point, these facets were slightly longer once upon a time, long ago, prior to 1950. This is what they use today. On the right is what you get if you order a Gibson style truss rod nut from Amazon. You can buy them in various prepackaged quantities. It's a very attractive price. Here's the thing. Whomever in China decided to fund this little manufacturing venture was only willing to pay for the interior tap. This is an actual 1032 imperial thread in this, I think. But I guess they didn't want to splurge on the extra 0.00002 grams of brass. So they skimped and they tapped a 7mm nut rather than the 5/16 that Gibson and other American companies have always used. It's slightly smaller dimensions. So it'll thread on just fine. But if you try and tighten it or loosen it with the usual tool, you will immediately round off these corners and render it probably unusable. The slightest amount of torque will do it, because it's sized perfectly to be ruined by a 5/16 inch wrench. So now you know. You do actually have to go out and find and pay extra to get the real thing. Okay, so just snug that up, and we'll see what happens when I put the strings back up to tension. Okay, so just barely tight will not do it at all. This is now about 21 thousandths of an inch relief. Okay, pay attention. That's a big adjustment. That's all it takes. So what I'm going to do is gently, but reasonably, flex the neck a little bit, which can let the truss rod settle in, and if there's any sort of binding going on inside the neck, it'll kind of take care of that. That took us right back to where we were, around 14 thousandths. Quarter turn. Gently massage the neck a little bit. So that was slightly less than half a turn on the rod, total, from the point where it was just snug up against the washer, and now we're down to 6 thousandths relief. Perfect, just fine. We'll leave it like that. So with that little adjustment there, we've come down a full 64th of an inch, just over 7/64 on the bass side, and on the treble, sitting at just over 5, which is nice. That is a significant difference. You would be able to feel that. Specifically in the center of the neck. When you're doing chords, A and B, you can really feel it if the neck is out of adjustment. Because, well, a couple of things. Number one, you have this sort of incline that's happening past the low point, which is usually around frets 6, 7. So you sometimes even get buzzing going on up here because the neck isn't straight enough. And also it just feels really difficult to chord. With the neck straightened out, the next thing to do is, of course, check to make sure we have enough saddle exposed above the bridge to allow us to take the action down. And in this case, of course, we have a whole lot. It's actually more than 3/16 of an inch tall on the D string, which is almost 5 millimeters, and it's basically on the cusp of being too much, like for having an overset neck. What happens if there's too much saddle exposed? Well, it really depends on how tall the bridge itself is. If you have a very tall bridge, over 3/8 of an inch, which this one is, it's about 9.5 millimeters, and you put a very tall saddle in it, you increase the torque or rotational force you're putting on the bridge. And this can have long-term structural consequences if the guitar has not been built to withstand them. And indeed, this guitar has quite a bit of a dip in front of the bridge and into the sound hole area. It's not catastrophic, but it's noticeable. Remember, Gibsons are built with a fairly substantial arch to their soundboards, as opposed to the almost flat Martin tops. The other thing is, the Gibson reversed belly bridge design has the anchoring point for the strings very close to the back edge. And it's a straight little cliff, straight down there. So all of that force pulling up on the pins and forward is centered along this very narrow strip right behind the pins. Versus the, what we'll call the standard belly down bridge, where the pins are almost on the center line. And you have this wide platform back here to absorb or to spread out that tension over a much larger area. This is likely the reason that Gibson for a long time used screws to try and hold the bridge in place. And it's also the reason where we think of Martin tops as bellying up behind the bridge. The Gibson ones, they're already so domed that it's not very apparent, but when these guys distort, it's usually a really wicked, abrupt kink in the top right back here. So if the bridge comes off, it can be quite difficult to put them back down again because it's bent. All of that is to say, if we increase the height of the saddle on an already tall bridge, we exacerbate all of the usual things that go on. So When I do a neck reset on these, I usually shoot for about 3 millimeters or 1/8 of an inch saddle exposure on the D string. If we want to take the action down on a guitar 1/64 of an inch, or the metric equivalent, or whichever unit you prefer, we measure that at the 12th fret. So we need to double that amount and remove it from the saddle height, because we measure at the halfway point along the string length. We have about 7/64 in this case. I want just under 6/64 on the bass side, so I'm going to remove a 32nd of an inch from the saddle height to begin with. Maybe a hair more. A hair being 5/1000ths, about 0.1 millimeters. And I'm going to remove approximately a 64th of an inch on the treble side, which is going to bring us hopefully somewhere around 4.5/64. Try and keep your bridge pins in order. Seems ridiculous, but each of the holes in the bridge has been reamed to fit one of these things perfectly. Try and remove the saddle. It is very tight. Not removable by hand. I have this pair of old nippers. It says blunt on them. They've actually been ground smooth on the face. So I can grab hold and not worry about cutting this thing in half. A little bit of pressure. Good snug fit. And in this case it's very obvious which side faces front or towards the headstock. I usually mark it with a little pencil line. I can see where the E strings are from the grooves on the top, and I'll just transfer that to the bottom of the saddle. I'm going to mark 1/32 of an inch for that low E string. And like I said, I'll just, eyeball it a hair above this line. And we will do 1/64 of an inch, which is almost nothing. We'll connect the dots. Sometimes it's easier to make a scribed line rather than a pencil line, especially if you're going to go back and forth and do a lot of fitting. That line can get pretty wide and sometimes even disappear where the scratch is not going to. If you need to see it better, of course, you can always get your fine mechanical pencil and run that down this little tiny score mark. This is a sanding block that's got 120 grit paper on it, and I often use this like a shooting board. I'll actually put it here and hold the block upright and run it back and forth so I can watch the pencil line very easily while I'm removing material. And in this case, where I'm doing a slanted cut, it just makes it easier to see. You can, of course, also do this like this. It can be more difficult, I find, to hold the saddle straight up and down. There are ways around that. You could get yourself a block of wood with a straight face on it, clamp this in place, and then hold that up against there and register against it. And of course there are beautiful and expensive jigs that will hold this perpendicular to the sanding surface. Sanding surface itself, you could get yourself a piece of machinist's grade granite surfacing block which has been milled to exacting specifications. You could also use a piece of MDF. I check this block every once in a while and it stays pretty darn flat, so it seems sufficient for my needs. So I'm sighting down from above, obviously, and keeping track of progress. And again, because this is a tapered cut, I'm going to start removing material at the far end where the cut is deepest. And it's a bit of an art. You have to sort of guesstimate where this straight line is going to end up, so that you don't end up prematurely passing the line on this side while not yet hitting on the treble side. Now you do every once in a while want to check to make sure that you're removing material in a way that's keeping the bottom perpendicular to the sides. You don't want an angled bottom, usually. And of course you want it flat. Okay, I'm approaching my score mark. Can check it with a straight edge. I can also check the bottom of it too to make sure that that's perpendicular. and it is. In the case where there's a hump in the center, it can be kind of hard to remove that. Your hand naturally kind of follows the curve, so in those cases I will take a razor blade and use it as a scraper and remove, a small amount of material in the center, feathering out towards the ends. And I mean, it's very slight. But it also means that when I put the block up, it's contacting at 2 points rather than in the center. And these last few strokes will make sure that it's good and flat. Of course, it's a good idea to check and make sure the slot in which the saddle sits has also got a flat bottom. Sometimes they do change shape over time as the guitar expands and contracts or domes up or down. Well, that's something to recognize, is that when you put string tension on this top, things are going to change slightly. The rotation might be different from when it had the taller saddle, which could affect the overall height of the action. Usually this happens in the really lightly braced soundboards, oftentimes the ladder braced ones, those parlor guitars you've seen me working on in recent months. Those have tops that are so thin and so movable that making a 1/16 of an inch change in the saddle height, one direction or the other, can have big consequences on where the neck and the body there's a symbiosis there. So I managed to hit the mark perfectly the first time, right on the button, exactly where I want it. However, as sometimes happens, the domino effect takes over, and lowering the action will reveal issues that we couldn't experience before because they were being hidden by the high strings. Namely, in this case, the nut slots are cut too low. The low E especially. Which is one that doesn't usually wear in to any great extent, so I don't know. Is this the original nut? I don't know what they were using in Bozeman around that time. I know Ren Ferguson was in charge of production, and he was really pushing them to use more historically informed materials. He was even trying to get them to put hide glue back into the rotation. So who knows? I suspect it's not because, well, it just doesn't look like a Gibson nut. The finish on the side of the neck doesn't carry on over the sides of the nut itself, and it isn't. So, but it is a bone nut. It's pretty well spaced. It's nicely aged. It needs to be 11 thousandths of an inch taller. Is it okay to shim a nut? I have no problems with shims if they're done carefully and bonded to the underside. I don't want a loose shim. I don't think that's a good thing. This already has a shim under it. I'll measure that and replace it with a bone shim and add the 11 thousandths onto that as well. Here's an old bone saddle which was salvaged out of a guitar, and I'm just going to glue that to the base of the nut. I'll leave it over long while I do the sanding to the final thickness. It's how I'm going to actually measure the thickness. I'll be able to check on the ends to see where I am. Put on a little bit of medium viscosity super glue. I'll just stick that down. Some of you in the past may have seen me use mahogany shims, which is fine as well. Generally I won't use those if it's more than about 20 thousandths thickness. In this case I'm going to need about 32, and it starts to appear a little bit funny. So I use the bone in times when it's more than 20 thousandths, or a single sheet of veneer. Here's why I left it over long. I can use my dial caliper. Of course, raising the nut height has the effect of slightly raising the action. Enough that I want to go back and take another little tiny sliver off the bottom of the saddle to make it right. And you'll notice that I'm doing all of this with the original strings, because it just doesn't make sense. Might as well do all of this back and forth thing and removing the strings and putting them back on again with the original set rather than messing up a brand new. This is from an era when Gibson really didn't do any recrowning of their frets at the factory. They just sort of sanded them flat and then just sort of rubbed over the edge with a piece of sandpaper. So they're very flat on top, which can contribute to some buzz and just not all that agreeable to play on. So I spent some time recrowning. And then, of course, polishing. And here finally is the mystery. This is a shot of the bridge pad, and you can see a line of plugs in there for the pinholes. These go all the way through from the top, and they don't really align with the usual wear pattern you'd see when ball ends pull through. It's more like the pinholes themselves were misdrilled, then filled, and then the bridge repositioned. The thing is, there's no evidence on the outside of the guitar, at the front end of the bridge, of that 1/8 of an inch or so movement. It's uninterrupted, unblemished lacquer there. Was this done at the factory when someone glued the bridge on in the wrong place? Someone caught it, they pulled the bridges off, scraped the top, and then resprayed the lacquer? Very strange indeed. So that's that. The action is now a full 20% lower than when it arrived, which I think is pretty good. Imagine taking your car in for a tune-up and coming away with 20% better gas mileage. The straighter neck makes bar chords easier to play, especially in the center of the neck. The nut slots of the proper height means there's not going to be any evil buzzes when you're playing in open position. And it's back to being the musical workhorse of legend and lore. Up next we have an Ibanez. This is an art core, rather spiffy looking. This is the AFS 75T, fairly early one, as they were introduced in 2002. This one, according to the serial number looker-upper thing that I used, suggests it was made in September of 2003. So it's just had its 20th birthday. Happy birthday. This one says it was made in China, but again, the serial number thing suggests it was made in the Samick factory in Korea. I don't know. Later on, they were definitely made in China and Indonesia. This was discontinued in 2020. There were a number of different combinations of woods and other materials that changed over its production life, as these things are. It's sort of a, kind of inexpensive hollow body archtop. The current owner notices that the volume pots are pretty crackly. But more than that, they also seem to only function for a very short length of their rotation. So this gives us an excuse to talk about potentiometers. Pots, as we like to call them in hepcat parlance, are variable resistors. There's a little circular track in these things, made up of a material that resists the flow of electric current. And the higher the value of the pot, which is usually printed on the case somewhere, the more resistance it has. So we connect the wire carrying signal from the pickup to the beginning of that little track in there, where there is practically no resistance. Electricity just goes in and comes right back out again. Yes, there is some tiny bit of resistance. We don't talk about that. We connect the other end of the track to ground. Usually in guitar stuff, we end up soldering it to the case of the pot itself because this has to be grounded anyway, and it's just an expedient way of doing it. By turning the knob, we get to change the amount of the resistance that current is facing. And a certain amount of high frequency gets bled off and sent to ground. A higher value pot with more resistance makes it more difficult for those high frequencies to get shunted away. This is the reason that single coil guitars, Strats, Telecasters, a lot of Fender stuff, which are just naturally bright, they usually have 250k ohm pots, which let more of that top end bleed off. Humbuckers are darker by comparison, and using 500k ohm pots, more of those highs are preserved. Now you can put a 250k pot on a humbucker, but you might notice that it's very, very dark sounding, kind of muffled. So there are different resistance values, but there are also different curves or tapers to how the resistance happens. There's a linear taper, which, you think of a graph here where the resistance goes up like this. it's a straight line. It's a very smooth rise in resistance from the beginning of the track to the end. And that would seem ideal, really, and proper. But for some reason, the human ear and the human brain don't really process auditory input that way very well. It doesn't match what our bodies do. And some weird things happen. So for a good part of the travel, it sometimes feels like nothing's happening. For most audio applications, remember, potentiometers get used in all kinds of non-guitar related circuits too. A logarithmic taper is used, which is also called an audio taper. The resistance in these pots is not a straight line. It's a curve. It starts slowly and then speeds up. The thing is, different manufacturers use different curves. Some get bunched all towards the end. Some are, slightly more like a linear taper. So you can get some where all the action does seem to happen in a very tiny fraction of a turn, and others where it's more spread out. To make it more complicated, there are also pots that reverse the whole equation. All the resistance seems to happen at the front end. Those would be the ones that you would use for a left-handed guitar. If you go shopping for them, you will sometimes see pots described as A, as in this case, or B. A for audio, B would be linear, if you're in North America. In Europe, strangely, it's the exact opposite, which can cause all of the situations that you think it could cause. There are people who swear by certain combinations. Audio snobs, Papa always told us audio taper for volume, linear taper for tone, and never after Labor Day. Or the opposite. Stuart McDonald, purveyor of guitar-related things, in a stroke of what might be genius, says, forget you nerds, it's going to be audio taper or nothing. They don't sell linear tapered stuff, because they know what would happen. The thing is, if you give people too many options, a certain small percentage of them will become obsessed to the point of complete and utter destruction. I know this, being a person who used to handle returns for a company that sold good stuff. Like I said, there are a lot of different tapers used by different companies, and even within the same company's products, there can be variances. If you want to learn more, get Jerry Hayes' book here, Complete Guitar Wiring. It goes into it in detail, but it's easy to understand. There are a whole bunch of other rabbit holes to go down as well. Differences between these things, manufacturing differences, tolerances, and things like shaft diameter. This is an alpha pot made in Korea. This is a CTS pot, working with North American dimensions from the past, which is larger. Things like the length and number of splines on the top of the shaft here. Usually the CTS pots have more than the alpha pots. Also construction materials, brass shafts. There are aluminum shafts, steel shafts, split shafts like these. There are also solid ones, which I don't happen to have at the moment, which work best with a set screw or grub screw. So yeah, let's give it a try. Yeah, so this is, you got about from 9 to 10. Not too bad, actually. As for the dirt and crackles, man, F-hole archtops don't like living on a stand in your house. Especially in a house with hairy pets or ingestible smoke products. Or if you live next to a quarry where they're pulverizing stone, or upon maybe the wine-dark sea. Fuzz, dirt, salt. It all finds its way inside and sticks to the components. And as we've discovered in previous videos, pulling these harnesses out and shoving them all back in again can be a very annoying task. Of course, this has a nice set of fairly close to brand new flat wounds on it. Try and preserve them, I guess, because budget's an issue. I will be as gentle as possible. Capo them to the neck and just sort of gently coil them in a not too tight coil. If all goes wrong, well, we're putting new strings on, I guess. Surprise, surprise. Once again, one of these things is not like the others. That guy there is a larger diameter washer, and it seems to be a different style of pot. It's a wonder that it's the one that makes the funny crackly sound. It's one of these efficient designs where they used not even a centimeter more wire than required. So, not really going to tuck that out of the way somewhere. Yes, this takes a 1/2 inch, whereas these take 7/16 or 11 millimeter. Some slight variance at play. Compelling evidence here as well. That bridge volume pot has a bunch of tear out around the circumference, suggesting it was drilled by someone who didn't really care. The other ones all have pretty clean entrance holes. Strangely, it is superficially very similar to the other pots, and in fact looks like it might be factory. And the only thing different is the shaft diameter. On this case is just about 370 thousandths, and the other ones are all 310. Who knows? These are small-scale mini pots. I'll remove the wiring, taking note of where it goes. And I'll reinstall those on a new pot. As you can see, I've gone with a full-size CTS pot because that will fit inside the hole that's been drilled in the guitar. For the wires that need to go to ground, I make sure to heat up the pot casing well. I apply a little blob of solder there. For work like this, it's almost essential to have a set of helping hands, which are little clips that kind of keep the wires where you want them to be, sometimes. Other times you just use your thumb, develop a thick callus, and lose your neurosensitivity. The other thing about helping hands is they never keep the part in exactly the right location where you set up when you were arranging the shot, so your carefully constructed close-ups end up looking like this. Just to confirm, these were linear taper B-style 500K pots. I did the pot for the neck pickup as well. Rather than try and drill for the neck pot, I used a reamer to upsize it so the shaft would fit. For the closer pots, I could reach in there with my pinky and shove them up in towards the hole and hold them steady. For the more distant ones, I had to tie dental floss around the shaft and tug and pull, and on a couple of occasions lost them back down the hole again and had to redo the whole thing. But, you know. The replacement pots, of course, had finer knurling on the shaft, so the standard knobs that came with the guitar wouldn't fit on those. I had to heat up the ends of a spare pot that I keep around for this purpose until it gets quite hot, and then thermal form the recess in the knob. You can see the pot has become hot enough that I actually have to wear a leather glove. And there we have it. The logarithmic pots give you a longer range of adjustment. Or at least they proceed that way.